Welcome back for more math with 1.4. Now we're going to talk about what happens when there are variables on both sides of the equation. So we're going to solve with variables on both sides and identify when an equation has no solution, infinitely many solutions, or one solution. So those are some of our options here. Okay, so I'm going to come over here to the one solution and just start solving it, okay? I usually like my variables to go on the left and for my things without variables to go on the right. So there's a plus 3 here. I'm going to subtract that 3 to the other side. You can pick whatever sides you want. I just like my variables on the left. So my negative 3's cancel out, or my 3's cancel out. And over here, look, the same thing happens. So they both went away. Alright, so now we have to get our x's onto the same side. Well, this is a positive 3x, meaning I need to minus 3x to get rid of the whole thing. Now, some of you might be like, but we normally divide by 3. True, if we only want to get rid of the 3, but I want the whole thing to move over here so that it's with the other x's. 2 minus 3 is negative 1. And 3x minus 3x is 0. That's what we wanted to have happen. So now I have negative 1x equals 0. So I need to divide by negative 1. 0 divided by negative 1 is 0. So I get x equals 0. That's a solution, guys. It's okay for x equals 0. In fact, one of the problems on 1.3 had that answer. Okay? So what's going to happen over here is that there is a variable left, and it can equal any number including 0. So it's okay if it equals a number, even if it's 0. 0 is a perfectly fine answer. Okay, now let's see what happens on the no solution. I'm going to move this 3 again because I want it to be over here with the other thing that doesn't have a number. And then my 3's cancel, so I just have 2x. I subtracted that 3. And then over here, my 2x. And 6 minus 3 is 3. Then I'm going to subtract these x's to the other side of the equation, because I want them to go across my equation wall that I should have drawn before. And I get, what? 0 x's. There's nothing left. These both canceled out. And then it equals 3. Well, wait a second. Does 0 equal 3? No, it does not equal 3. It will never equal 3. So what we have going on in this problem is a no solution. Okay, that's never true. That's not going to happen. 0 does not equal 3. Okay, not true. Okay, and what happens on this one is the variables eliminated. What that means is they all went away. So they're all gone. There's none left. So they all went away. And what's left is false. Okay, so if that's not true, then we have a no solution. Now let's look at an infinite solution, or infinitely many solutions. I'm going to start the same way. I want this to move over to this side. So I'm going to draw my equation wall and subtract my 3. Boom, cancels. Wait, what's going on over here? Boom, cancels. So I have 2x equals 2x. And I know there's not a whole lot left. We're going to still kind of treat it like normal, though. And I'm going to subtract these two x's to be over here with these. And that cancels them out. So I have 0 left. And what happens over here? It cancels them out again, and I have 0 left. Well, does 0 equal 0? Yes, that is true. So that means that we have what is called infinitely many solutions. And I know I did not leave quite enough space to write all of those words. You can just draw an arrow up here if you want. Okay, what happens here is the variables cross out. Hey, cross out and eliminate are the same thing if you prefer saying that. And what's left is true. So basically these two are what happens when there's no variables left. Either it's true and infinitely many solutions, or it's false and no solution. Okay, let's look at what this looks like just if we're solving regular equations. Some of these are going to be no solution, some of them are going to be one solution, and some of them are going to be infinitely many. So, what do we do if there's a number in front of parentheses? We distribute. So I need to take half of 8x and half of 10. Half of 8x is 4x. Half of 10 is 5. Equals. And then sometimes I'm going to have you guys do this. I'm going to go ahead and add these two things together. I have a 7x and a negative 3x on the same side of my equation wall. So I'm not going to do the opposite since they're already on the same side. 7x plus negative 3x is 4x. Okay. And then I'm going to subtract my 5 from this side so that it's over here with the other 5. And I have, boom. Wait, it happens over here too. So I have 4x equals 4x. Now, some of you are going to be like, oh, that's the same thing on both sides. We're about to subtract them and they'll both go away. And you're right, I'm going to go ahead and do that step. They both cross out. So what I have left is 0 equals 0. And since this is true, we have infinitely many solutions. And I'm going to go ahead and write that over here. And I'm just going to write infinitely many for that one. Okay, then I'm going to come over here and solve the next one. I'm looking to see if there's a number in front of a parentheses, and there is, so I have to multiply these by 2. Always look for the parentheses first. 2 times 6x is 12x. 2 times negative 5 is negative 10. And then the other side just stays the same. Then I want to get rid of this, so I'm going to add 10. And look, they both cancel out. 18x equals 12x. Okay, I'm going to subtract these 12x's over to this side. So they cross out. And over here, 18 minus 12 is 6x. So we get 6x equals 0. A lot of us freak out a little bit because there's a 0 in there, but we want to divide by the 6 still, because this is 6 times x. So to get rid of the multiplication, we divide. You can do 0 divided by 6 in a calculator. 0 divided by 6 is 0. Okay, so x equals 0. And that's your answer, guys. X equals 0 is an answer. You don't need to say anything afterwards. You don't need to tell me if it's one solution. You only need to tell me if it's none or infinitely many. Alright, I'm going to draw my equation wall first on the next one. I do not see any parentheses. Perfect. But I do see things I'm allowed to add together. Like 9x minus 6x. They're on the same side, so don't change the signs or anything. But 9 minus 6 is 3. And then over here, 10x minus 7x. Again, they're on the same side, so we don't need to switch anything. 10 minus 7 is 3. And then I'm going to pause really quick and show you something. See how these were the exact same? That's what gave you infinitely many solutions. These have the exact same number of x's, but the second number is different. This is going to end up giving us no solution in a minute. And then over here, if there's the same number without an x on both sides, that's always going to end up giving you x equals 0. But that one's not necessarily one you have to remember. Just if they're exactly the same, that's infinitely many. If the x's are the same, that's no solution, if the other piece isn't. But I'm going to go ahead and move this. Since it's being subtracted, I'm going to add. Cross out. Negative 14 plus 10 is negative 4. Then I want my x's together, so I'm going to subtract this 3x, subtract the 3x, and what I have left is 0 equals negative 4. That's not true. This is false. So what we have here is no solution. All right, one more regular equation. I see parentheses, so my first thing is going to be to multiply the 4. 4 times 2x is 8x. 4 times 2 is 8. And then the left side doesn't change. So I'm just going to copy it on down. Okay, notice how there are not the same number of x's on each side. So that means we're probably not going to have one of these special ones. Okay, I'm going to go ahead and subtract my 8. Sorry, I almost wrote the wrong thing. Ignore that. So that it cancels out. Oh, I was looking at the wrong side. If I do minus 8, is that going to cancel? No, I need to do plus. There we go. There we go. Okay, 10x equals 8x plus 8 plus 8, 16. Subtract the 8x to the other side so that it is with the other x's. And now I have 10 minus 8, 2x equals, boom, 16. And then most of you know at this point, or should be pretty comfortable with, dividing by that 2. 16 divided by 2 is 8. Okay, so look, we have normal equations and we have some that are infinitely many solutions or no solution. All right. What we're going to do down here is use those key features to decide. So for instance, over here, I have negative 4x on this side and 4x on this side. Since that's not the same number of x's on both sides, they won't cancel out. So this one is going to have one solution. Okay, on the next one, I do have a 6x on both sides. So that means it's going to be one of these two. And then I have to look and see, is the other number the same too? It is. Even though it's written in a different order, it's the same information on both sides like this one. So that's infinitely many. And I'm going to show you guys a trick. This means infinity. And we can use it for infinitely, if you don't feel like spelling it out all the way. You can also spell it out all the way if you don't like drawing that symbol. Some people turn their paper and do it like a sideways 8. It's called infinity because if I keep drawing it, it just keeps going forever and forever and forever and forever and forever. Okay? Next one, I have two completely different values for x on each side. So that means they aren't going to cancel out, and we have one solution. Down here, I do have the same number of x's, so I need to look and see, is this number the same? It's not. 3 isn't going to equal 12 after these 5 x's cancel out. So that's going to be no solution. No solution is if you, again, have the same number of x's, but the other number isn't the same. The constant isn't the same. Okay, now this next one is a little tricky because, look, I have 7x plus 4x. Well, that's 11x. Is that the same number of x's as over here? No, so they won't cancel out, and we just have one solution. Again, our directions here were just to determine how many solutions it has without solving. So I'm not looking for the answer, I just want to know how many it's going to have. It's just kind of practicing that. And then over here, 8x minus 3x, those are on the same side. Those would make 5x. So that's the same, and then they both have a 3. That would be infinitely many, because everything's going to end up being the same on both sides.